Hello guys, so we are going to continue discussion with respect to statistics. In this video, we are going to understand about Bayes statistics, and we are also going to understand about a very important theorem which is called as Bayes theorem. Now Bayes theorem will be super important for a machine learning algorithm which is called as naive Bayes, because this theorem is completely based on probabilities. Okay, so we'll try to understand what is Bayes statistics, and then we'll try to understand about Bayes theorem also. So to begin with, over here is the definition. Bayesian statistics is an approach to data analysis and parameter estimation based on Bayes theorem. So with the help of Bayes theorem, we will try to do data analysis. We'll try to even estimate the population parameter over here. Okay. So let's go ahead and understand with many examples about Bayes theorem and all. So in Bayes theorem, first of all, we need to discuss about a probability concept like independent events and dependent events. So whenever we talk about independent events, number one, we will talk basically about independent events. And obviously I will be showing you a lot of example independent events. Okay. So this will be independent event. The second one that you really need to know is about dependent event. Okay. So what exactly is independent event? So if I probably consider an example like rolling a dice. You know, the outcome of a dice is 1, 2, 3, 4, 5, 6. Now from this, you should know that the probability, whenever I roll a dice, the probability of 1 will be 1 by 6. The probability of 2 will be 1 by 6. Like this, any probability that you probably calculate with respect to any outcome, it will be 1 by 6. So here you can basically say all these events are independent because one event is not impacting the other event. The other example may be like tossing a coin, right? Whenever we toss a coin, we get a probability of head. We get probability of head is equal to 0.5 and probability of tail, we are going to get 0.5. So every time we toss, either one of this event will be coming. Okay. So the probability is equal. So one event is not impacting the other event. Like if probably head comes right now, the next event is not impacted. All the events are independent. Now, if I talk about dependent events, this dependent events, I can definitely show you with an example. Let's consider that I have a bag of marbles. I have 3 yellow marbles and I have 2 red marbles. Let's say in the first event, I try to take out a red marble. So what will be the probability of red, right? So over here you have 2 reds and total number of marble is 5. So you'll have 2 by 5. Now after taking out the red marble, let's consider that you want to take out a yellow marble. So now I want to take out a yellow marble. Now with respect to this, what will be the probability of yellow, right? See, this event has already occurred. When this event has occurred, that basically means I'm taking out the red marble. So the total number of marble that are left in the bag are 4. So if I now try to calculate what is the probability of yellow, it will be very much simple. It will be 3 by 4 because there are 3 yellow marbles and total number of marbles are 4. Now this kind of events are called as dependent event because after this event has occurred, you can see that it is impacting the other event since it has reduced the number of marbles from 5 to 4, right? So in order to solve this dependent event, we basically use this, right? How do we calculate a probability of red and yellow? That basically means first red event is occurring and then Y event is occurring. So this one, we can basically write it as probability of red multiplied by probability of yellow given red event has occurred. Okay, given this red event has occurred. So let me mark this in red color. Given red event has already occurred. This statement, this formula that we see is basically called as conditional probability. Conditional probability. Super important. Now based on this, so this is the equation that we have derived for for a dependent event because one event is impacting the other event. Now what I'm going to do is that I'll write in a very generic format. Let's consider probability of A and B. Now I can also write this as probability of B and A because both are commutative, right? If I try to calculate it in this, now if I go ahead and calculate what is probability of red, it is nothing but 2 by 5 multiplied by 3 by 4. So this is nothing but 6 by 20. So this is the probability of red event and then occurring with after red, Y event is basically happening. Okay, the yellow marble is basically 10. Now let's go ahead and consider this. Probability of A and B, I can also write it as probability of B and A. Both are one and the same. Now with respect to this, I'll expand this equation. Now if I expand this equation, it will be probability of A multiplied by probability of B given A. Probability of B given A. Yes, we can expand this equation in this way based on this formula that we have. This will be equal to probability of B multiplied by probability of A given B, right? B event has already occurred. Now finally, I can probably write this as probability of B given A is equal to probability of B multiplied by probability of A given B, and this will go to the denominator. The probability of A will go to the denominator, right? So this equation that we get, right? This equation that we get, this is nothing but this is Bayes' theorem. I'll make you understand what is the importance, okay, and what we can basically do with this. This equation is basically called as Bayes' theorem. And the similar part of this equation I can also write like this. I can also write something like this. Probability of A given B is nothing but probability of A multiplied by probability of B given A. Why I'm writing like this? Because in most of the textbooks, they will be showing you this equation also. And this is also Bayes' theorem. Okay, these both are one and the same with respect to different events. Here I have used A event and B event, both the notation. Okay. Now let's understand one very important thing. What are all these parameters? So first of all, A comma B, these are nothing but events. Okay. And then if I probably write probability of A given B, it is nothing but probability of A given B is true. When I say B is true, that event has already occurred, right? Similarly, if I write probability of B given A, this is nothing but probability of B given A is true, right? So I've mentioned both of them, right? And similarly, if I probably write probability of A comma probability of B, what are this? These are independent probabilities of A and B, right? Now let's go ahead and consider a data set. Okay, we'll try to understand in machine learning how it will be applicable, how it will be useful. Okay, let's consider I have a data set. Okay, this is my data set. Now I'll show you how this will be useful in machine learning. Let's say that I have some features like size of the house. Let's say I have something like size of house, number of rooms in the house, location. I have these three features and I have one more feature which is called as price. Now, can I use this three feature to determine the price or to predict the price? Yes, we can do it with the help of machine learning algorithms. And this scenario over here, let me give a generic notation. Let's say that this is my x1, this is my x2, this is my x3, and this is my y. These three features that you see, right? Size of the house, number of rooms, and location. These are basically my independent feature, my independent or input feature. And this is basically my output or dependent feature, right? We can use these three features to predict the price of this. Now, how using Bayes' theorem, I can basically use it or I can predict price. So in Bayes' theorem, we will go ahead and write the equation like this. Okay. And it is very much simple, guys. The same equation, what was there over here, in the same way I'll try to write. Okay. So I will go ahead and write what is the probability of y given x1, x2, x3. These events are already there. These inputs are already there. So I can write like this. And this will further be written as probability of y multiplied by probability of x1, x2, x3 given y, right? Divided by probability of x1, x2, x3. So this equation is a part of Bayes' theorem, okay, which is through Bayes' theorem, right? This entire equation is nothing but it is from Bayes' theorem. And we will be probably using this to calculate the probabilities of y, which is my output feature, right? Super important formula. If you know this, the Bayes algorithm is done from your side. So I hope you were able to understand about Bayes' theorem and how Bayes' theorem equation looks like. So yes, this was it from my side. I will see you all in the next video.